and you'll be doing a 6-minute registration for the dynamic topic.
Alright, my name is Duvic. Today our thermal topic is going to be diesel engine waste heat recovery system. These are just some introductory concepts. Pretty much what's going to be going on is that normal engines nowadays, most of your, not all of your energy from when the fuel is burned goes into driving the vehicle. A large percentage of it is released as excess heat. And what this system is going to be ended up doing is using that excess heat to generate additional power. And right now, it can be used as electrical. It's mainly going to be as electrical systems powering, regular household items or cooling systems, like for use in container ships. Right now, it's mainly being used in the large shipping industry because, as we all know, that the cost of fuel is going up. There's going to be tighter and tighter regulations for the use of fuels. And what's going to end up happening, go forward one. And then the other, the other way to actually, the other thing that it's going to be used for is actually to move the ship through the bar without using as much diesel. And this is actually an example of what a diesel-electric system would be on a tanker or a cruise liner. In gray, you'll see that the main diesel engines, and then in line with that is pretty much a large electric motor that will help offset some of the power requirements to propel the ship forward. The design purpose, as I said before, higher cost of fuel, the tighter EPA regulations on them. And the reason why it's mainly being used in large vessels is because they have a lot of space to put the equipment. This is just a diagram on the left over there is just straight without the waste heat generators on them. And you can see that the output is around 49.3%. But with the waste heat generators, you're actually going to lower the shaft output, but increase the total amount of energy that you're actually being able to take from the burning of the fuel. Basic principles, you're going to have the Rankine cycle, diesel cycle, Otto cycle, and in some instances the use of the Stirling engine. This is just a basic setup of where you have a boiler, a turbine, and a condenser. And these are the thermo equations that we're going to be that are going to be used in this process. The first model is strictly a. What ends up is that there's another half. I don't know if you all know what a turbocharger is, but it uses the exhaust gases to spin a turbine that will in turn spin a compressor. But in this case, you're actually going to, instead of spinning a compressor, you're going to be spinning a gearbox that's connected to a generator. And that's going to produce electricity. And this is just an example of what that looks like. And then here is the All right, the second type of system is actually a steam boiler turbine system, which the exhaust gases are run through a water heat exchanger boiler, which then boils the water, then that runs through a turbine and then turns a generator. And you have the standard single loop system on the left and the dual loop system on the right for high and low pressure sides of the turbine. And this is the third model, which is actually a combination of both, where you're able to add the first one, which was just like a half of a turbocharger, to a generator, but it's also linked up in line with a steam turbine generator. And this is the basic diagram on how that will work. I know it looks a little loud, but what's going to end up happening is that the turbocharger power generator will actually take exhaust gas off of, you know, the exhaust header that comes off of the motor, and because the pressure is actually decreasing because of the additional exhaust that's being used up by the turbocharger power generator, it will therefore increase the temperature that's going through the rest of the turbochargers that are normally there for the motor, which will in turn, as the higher pressure, the higher temperature, it will have a higher temperature going into the boiler, which will actually increase the efficiency of the boiler as it's turned into steam and then goes through the steam generator. All right, and this is just an efficiency calculator that are listed for just the power generator, which is the one that's similar to the turbocharger. It's 3 to 5%, and then you have the increase in efficiency for just the steam side of it, and then you have the increase of efficiency of the two combined together. And this is how it can be changed from a strictly ship-based technology to be able to use in our vehicles. Obviously, we have a lot less space to work with in vehicles, and from there, we're actually able to use the power generator or the turbo generator side of this PowerPoint presentation, which will therefore create electrical energy, but can be coupled with a Stirling engine that will also create electrical energy, which will be able to sort of make like a hybrid system, where you're going to have a bank of batteries that's going to be charging, and then no longer will the vehicle be responsible for its water pump, the alternator, the air conditioner, the radiator fan, which all draws energy in order to power those devices directly from the motor, which doesn't allow for as much power to be put towards the wheels. So that will actually be increasing its efficiency. And in conclusion, there are going to be certain vehicles that this is going to be able to work with. I believe that this is something that can be done right now. This is not some, experiment that's going to take a while. This can actually be done with us right now. But like I said, the only limiting thing is space. But I'm sure we can figure that out, with an increase, in technology, in a certain way that we can shrink these devices down. And also, it has to be an acceptable cost. No one's going to want to spend an extra $15,000 to make up $5,000 worth of fuel. It's just not going to happen. But like I said, this is very possible for vehicles now. And is there any questions?
Can you go to the efficiency slide?
Okay. Now, let's do it. Yeah.
So, like you talk about ships, like which models they use mostly?
According to what the research I've done online, it all depends on the size of the ship. If a container ship they require a large amount of electricity, because containers, more and more of them are becoming refrigerated containers, food service containers, and so they require a large amount of onboard power. So again, depending on the size, they actually end up using all three. But for the smaller ships, the power generator, which is again is like the turbocharger, is the one that they mainly use. And then as the ship's motor, pretty much is based on the motor, which is based on the side of the ship, is you have a power generator, just a steam boiler, and then you have the combination of the three.
And like you also talked about using Stirling cycle if we had to do it like in a non-stationary way. So like would that increase the efficiency more than the third one, or like it would be like a little bit lower than that?
The reason why the Stirling can be used in both the ship application and the automotive application, but the reason why I mainly listed the Stirling is for the automotive, because obviously we're not going to be driving around with a gasoline engine, a electric motor in line with that, and a steam boiler,
And I said that the efficiency lies in which range of these, if you use the Stirling engine.
The Stirling would actually, in coupled with the power generator, would be within the single loop boiler efficiency range. And but yeah, that's about it. Yeah. Any other questions? Yeah.
Did you see the new Ferrari came out with the electric motor and the gas motor on each other?
No, I didn't see that one. But I mean, it's fairly similar because you're able to get instant torque out of the electric motor for, obviously launching and, acceleration. And I doubt they probably have a hybrid system with that. Bank of batteries probably not quite matched up for performance. So, but I can definitely see this going with, your everyday driver to have a bank of batteries, an inline electric motor, and one of, the Stirling and the power generator in order to make the electricity for that, as opposed to the motor actually turning an alternator or a, yeah.
Oh yeah, a lot of BMWs now, I think they use like additive braking or something like that.
Yeah.
They take heat from braking and that like recharges the battery.
Yeah, their braking system is pretty much, instead of the energy being lost when you clamp down on the brake pads, on the rotors, they're actually, I've seen some where they actually can use somewhat of a electric motor or electric generator gear reduction system, so that it'll actually cycle through different gears depending on how far the pedal is pushed, and as you cycle through gears, it'll increase the ratio from the motor to the wheels, slowing the car down, but then that much RPMs going to the generator itself, spins it more and more and allows you to charge the batteries. Now, I don't know exactly what, you said BMW?
Yeah, okay.
Yeah, I don't know exactly, what their system is. That was just the one that I had seen before.
Yeah.
Anybody else? All right, thank you.